Okay, what a comparator does, it compares. I'm giving you a hint. I'm giving you hint for this. It compares a signal voltage applied at one input. It compares a signal input voltage, a signal applied at one input with respect to another reference signal, with respect to another known reference signal. So we have one signal which is called as the reference signal, and we made use of reference signal in case of log amplifier for controlling the temperature fluctuations. Here the objective of reference signal is to limit the output. Suppose we want the output to be limited in a particular range, then we can limit it, right? So let us see. So this is basically, it is a non-linear application of op-amp. So it is an open loop op-amp. First of all, the circuit that we are using, and open loop is non-linear in nature. It is an open loop circuit that is producing either positive VSAT. It switches between VSAT and minus VSAT. That means the output produced is a square waveform. It can be either plus VSAT or minus VSAT. Right. We will, I'm telling you the role of this circuit briefly, and we will discuss this in details tomorrow. So let us have an eye on the first circuit, which is non-inverting op-amp. From this you will get an idea how this circuit performs. So first circuit in this is non-inverting comparator. Am I audible to all of you? Yes. So we have a
Yes, sir.
non-inverting comparator here. Right, now we can construct the circuit for this. This is the inverting terminal. This is the non-inverting terminal, and this is the output here, across which we have connected the load resistance. This is load. You should be able to draw this. And why do we call it non-inverting? Because we are applying the variable voltage source here. So this is the voltage which is coming from a plant. You can imagine that this is the this is representing the temperature of a plant, right? And other terminal is fixed. So the other terminal, we are connecting a voltage source which is fixed, which is known to us. This is called as the reference voltage terminal, and we may use resistances also in between. So here we may use a resistance, and here we may use a resistance also. You can add a resistance to limit the current. So one resistance and another resistance, right? So you can assume that the voltage here is V2 and the voltage here is V1, right? Here it is V1, right? Output of an op-amp is equal to gain, open loop gain, which is A in this case, into V1 minus V2. Now I'm writing the equation here. Output equal to A times V1 minus V2. Now, can you tell me, if V1 is greater than V2, what will be the output of this device? And if V1 is less than V2, what will be the output in that case? Can you answer this question? I told you the answer of this question is the output can be either plus VSAT or it will be minus VSAT. It can be either in the positive direction or negative direction. Can you tell me now? Looking into the equation, if V1 is greater than V2, here in this case V1 is nothing but V1 is V in and V2 is V reference. Now, can you answer this question? If V1 is greater than V2, from this equation, will this equation be positive or negative? If V1 is greater than V2?
Plus Vset.
Right. So the output will be plus Vsat. It means that if the output was initially minus Vsat, if the voltage V1 becomes greater than V2, it will switch from minus Vsat to plus Vsat. And how about the second one? If V1 is less than V2, the output will be negative and answer will be minus Vsat. Right. So we can see the same thing in the waveform. Now, if we draw the waveform, you can prove it with a waveform also. If this is the waveform, now you can guess from here. This is the input. This is your signal. This is V in. This signal is V in. And this is our V reference. You can imagine that our reference level that we have voltage source, reference voltage source should be less than, it should always be less than the input voltage, then only we can control it. So you can generate the control points from here. If you look at these points here you get these points, these particular points you get, another point you get here, and so on, like this. Right. Now you want to draw the output. Now if I want to draw the output, this is the reference voltage. Now you can have an eye on this circuit, earlier circuit, V in. Now from this we get the output in this manner. Now if you look at this from 0 to this level, this is the range 0 to this level. If we look here, this is the range for which V in is less than V reference. Right. So what will be the output at this time? Between 0 to this level, what will be the output? Output should be, if V in is less than V reference, what is V in? V1 is less than, output should be minus Vsat, because I am discussing this zone of the waveform in which this is the level of V reference. This is the level here, right? So if our waveform, input waveform is increasing, it is increasing in this direction. So during this instant, the input is less than reference voltage. So output will be in the negative saturation zone. It will be here, right? And after crossing this point here, what happens once this point is crossed? V in becomes greater than V reference. If V in is greater than V reference, what is the output that time? Output at that point of time is plus Vsat. That means after this point here, this point, because the input voltage is increasing, it is more than V reference voltage. Therefore, the output will now switch from Vsat minus Vsat to plus Vsat. So the switching will take place. It will go from minus Vsat to plus Vsat. Then it will remain constant again. And again at this point, if you look at this point again, V in is less than V reference. Therefore, the output will again switch from plus Vsat to minus Vsat. And this process will go on. And we will get a square waveform in this manner. At every point there will be switching. The switching will take, right? So the switching of the waveform takes place. I'll redraw the waveform. We had some more points in between that we have left. This was another point here, right? So the switching will take place here also. Therefore, we'll get a waveform in this manner, and finally we will get a square shaped waveform as we get here. So this is called as the comparator action, and this is the output, and this is a non-inverting comparator. This is minus Vset on this side, on the lower side, and on the upper side we have plus Vset, right? And reverse of this will happen in case of inverting wave. Why do we call it non-inverting